from the last class? Anything anyone want to ask from the last classes?
No, I don't have any questions. I think it was a good introduction to MapReduce last week. So let's continue.
Okay. Okay, sure.
But I don't see your screen. Are you sharing?
Yeah, I'm yet to share.
Okay.
Okay. So let's do a quick recap what we discussed in last two classes, and then we'll again switch back to the MapReduce phase. So can anyone recall what are the three phases in the whole cycle of MapReduce?
Map, sort, and combine, and then reduce.
Yeah, it's map, sort, and shuffle, and reduce. So combiner is a totally different concept. We'll talk about the combiner concept also in some time. Yeah. And what is the input for a reducer?
It will be the output from the map job, which will be a key value. The key will be the same as what the output from key map is, but the value would be the iterable object.
Yep. Yep. And then we also looked into the someone has arrived. So okay, it's Umesh again. Looks like he's joining from two consoles. So and we also looked into how to look into the Hadoop file system. So I hope you remember we talked about the Java code also. We talked about the UI also. We talked about the console also. Right. I'm just trying to refresh so that you are okay. So I'm just sharing my screen. Give me a sec. Do let me know if you can see my screen. Visible to everyone?
Let me quickly check. I was looking at something else. Okay, yeah, we can see the screen.
Sure. Okay. So let's start. So we discussed that the output of the mapper goes to a reducer, and in between there's something called sort and shuffle phase, and how the data is key and values of the from the input data is really being mapped to the reducer phase, and how your data is processed. So let's look into a little bit more detail and the hello world of MapReduce world, and then we'll look into other concepts of MapReduce. So I think we were on this slide when we left. So this was also completed. Key and value pairs. So mapper basically consumes our key and value pairs. As we discussed in the last class, your data is somehow read into key and value pairs. How that is read, we'll just look into this, but with the help of readers. There's a concept of readers, record readers, so which basically read your data. So with the help of them, your data is read in key and value pairs, and mappers at the end produce a key and value pairs, which is basically an input to your reducer phase. And however, the value, instead of value, it goes in a list of values, iterable values. And reducer consumes a key and the list of values which are produced from the mapper and produce key and value pair. That is your aggregated data, which is what you did with the data, or your aggregated output, what you are doing with the data. And in between there was something called sort and shuffle phase, which is hidden to us, but we'll look into this, how this phase is basically helps us and do all this thing. I'll talk about that part also. Okay. So there could be the cases when you don't want a reducer. So in that case, you can directly produce the output of the mapper to SDFS, and in that case, your reducer would be 0. So there is an option to configure the number of reducers in my Hadoop world. However, I can't configure the number of mappers in my Hadoop world. In little time, you will get to know the reason why I can't configure the number of. I think we talked about in the last class the splits, or didn't we? We did not, I think. So in just 5-10 minutes, I'll explain you the concept of splits, and that will make then it will make sense to you why we can't change the number of mappers in the program. However, we can change the number of reducers, and that is configurable part. So we just look into this. Let's look into a sample program or another program that will give you a little bit more insight how the MapReduce phase works. Then we'll look into the MapReduce code. So your this thing said these are the two files, which is one is your each file contains different fruit names. So on the left hand side of my screen, you can see the input file, which is divided into two blocks over here. So your data is lying into two different nodes. Okay, and while explaining this example in detail, I'll also explain you the concept of splits also. So these are the two files which are lying into two blocks over here. And my objective of this whole exercise is I want to count the number of apples appearing in my program, basically the count of different fruits appearing in my file. So these are the two blocks of my file. We read those blocks one by one, so this is the input to a mapper phase, and this will also have a key which is of no use. So we'll just ignore that key. And in the mapper phase, what we do is for each word we created a key with the word and the value as a count. So that word was appearing once, so we produce a count of 1. The orange was appearing 1, we produce a count of 1, and so on. So in the mapper phase, for each record which we read, we just produce the key as a word and the value as the count of the word, which is nothing but 1 because that is a single word. And same we did for all the records which we read one by one. So in the sort and shuffle phase, your data is sorted, and somehow your data will look something like this. And in the reducer, you will get apple, comma 1, comma 1, comma 1. In the reducer side, what I'm doing is for each key, I'll just sum up the values and produce something like this: apple, comma 4, grapes, comma 1, mango, comma 2, orange, comma 3, and plum, comma 4. And this will produce a number of fruits appearing in my file. So somehow, so image looks like you are just connecting or disconnecting. I'm not sure whether you can hear us or not. If you can't hear us, just ping us on the chat window, and I think we can help you somehow. So basically, this is how you basically divide your problem into key and value pairs. Does it make little bit more sense from the previous class how you basically divide your data into key and value pairs?
Yes.
Okay, so let me open an Excel and let's talk about. Just give me a minute. I'll just share an Excel sheet. So let's look into a few other interesting concepts. What will happen? Everyone can see my Excel sheet, right?
Yes.
Okay. So let's say the data was something like this. These are two data nodes: data node 1 and data node 2. Okay. So as we looked over there, I'm not sure if anyone of you have a number of Umesh. Just cross check with him. It looks like he's not able to connect or something, and that's the reason I've shared the Skype IDs also. So if you have any problem, just ping me on the Skype. I'll be available on the Skype all the class timings, and that is a beautiful way to communicate if there are problems are facing with the in the communication in another channel. So let's say these are the blocks on the data nodes. So say this is your data node 1, this is your data node 2. Okay, and these are the blocks in your data node. So they have something like this: apple, orange, plum. So This is one block, and this is another block on data node 1, data node 2. So say it has grapes, banana, and so on. Okay. So now what will happen is into my mapper phase, the key and values will be produced. So there's something called record reader in between. We'll talk about that thing in detail in some time, but now record reader reads the data something like this. It will produce a key of this data. That is nothing but the binary offset of the row. I'll talk about that. So the key would be something like this, and the value would be nothing but this thing. So this is what a record reader will do. And say 90. That means how many bytes are offset. That is the byte offset value of the key. That is say 180 and so on. So this is your key and value pair which will be read by the record reader.
So is byte offset is the size of the data, or is it?
No. These are just the bytes offsets from the initial start of the data. So say these are 89 bytes. So this will be 90, something like this.
Oh, I see. Okay.
So this is the key which is the default key which is given to your data if you use a default record reader. But there are other record readers also. We'll talk about them in some time. So this is how your data is read, and for this also. And in the mapper phase, what you did is you broken up this text. So you ignored the key totally. You was considering only the value. So in the mapper phase, I'll just ignore the key. I'll just work with my value. So for each value, what I'll do is, for each value, I'll use what do you call that? Some text operations or something like that, and will break my value, comma separated. And for each word I found in my data, I'll just produce something like this. So I broke this to apple, orange, plum, and after breaking it up, I'll produce an output, and I'll produce output something like this. Key and value is nothing but these things. Oh, sorry, key is nothing but these things. I'll produce, and value I'll produce as 1, 1. And for each block, I'll keep on doing like this. Make sense till now? Right?
Yeah.
And in the reducer phase, what I'll do is I'll get something like this. So for each apples, I'll get something like this. Reducer. And the reducer phase, I'll get something like this. I'll get key and value something like this. Something like this, okay? For others also. So what I'll do is for each key, I'll just create a for loop of values and do the sum and produce apple 4 and so on. Till now it's clear to everyone, right?
Yes.
Yeah. Okay. So now how my lines are read from the whole block. My default separator for your so over here you can see the record reader has given the first line as a key 1, second line is 90, and third line is 180. So practically your data was something like this.
So Umesh is having some audio problem. He's not able to join.
Yeah, that is what I was wondering. Yes. So can you ask him to join it from US toll-free number?
Yeah, I think he's going to try that. I think he also pinged you, I think.
No, I
think I can hear you from my home phone.
Okay.
So
okay, fair enough. So
I should be there audio.
Okay. So whenever any such problem you will face, I've shared. So I've sent a request on Skype to everyone with the ID admin.design Pathshala. You can just add me up, and in the class timings I'll be available on that Skype ID. So for any such challenges, that's the only reason to use the Skype. So what I was saying is practically your data, your data was written something like this. After /pump, there was a control and kind of character. Over here also there was control and kind of character, slash and kind of character, that is new line. And over here also there was something called new line, and that's how your each line was read from your data. So that's how your record reader was able to create keys and value pairs. I'll just put you on mute, other I'm hearing a lot of echo. So this is how I can, my record reader basically was able to segregate my records, and keys and value pairs was created. And your next block 2 was lying over here, and so on. Now let's add some complexity to this problem. Let's say my data was something like this.
Sorry to interrupt, but the Excel sheet is not visible to us.
Okay. Sorry. It's visible now?
Not yet. Yeah, now it is.
So
it's gone again.
Yeah, just a minute. Oh, actually, I was trying to figure out what is the problem he was facing, so I changed that thing. Okay. So what I was saying is after each of these things, there is a slash n or new line kind of character. So that's how your record reader is able to segregate your each key and value pair. So for one line it created one key and value pair, for second line it created another key and value pair, and so on. And this is how your record reader was able to create keys and values. So slash n is a default segregator for each record when it is read from the blocks. Makes sense till now, right? If it does not, just ping on the chat window. Now let's add some complexity to this situation. Now say the data which was divided, so this was your block 1, which is highlighted in color light green over here, and this is the second block which is highlighted in the color light blue kind of thing. So now let's add some complexity to this problem. Say my data in this block was be able to fit something like this, and rest data gone to this block BA, NA, slash n, and like this. Now what do you think will happen? How your record reader or mapper would work, how your reducer will work, how you would be able to create keys and values? Can anyone guess?
I think the whole record will go to either node 1 or node 2. It will not be.
Yes. So what will happen up is So what will happen up is when this guy starts reading it, it will not find the end of this thing. So over here the picture comes in again, the interaction, all those interaction will happen with your name node by your process who is running your job. So it will find out which is the next block for this data, and it will communicate with that corresponding task tracker and request for the data, and it will get this data till this data over here, and this data will be used and will be passed over here. So this is an extra data which will be transferred over the network. Sorry. This is an extra data which will be transferred over the network, will reach over here, and this whole thing will be created as your one record and will be read over here. And this person will only start from here, reading start from here. So this is how your if your data is segregated or you cannot create a whole record, there's inter-node communication which happens up to create a whole records, and this is where your record readers comes in picture. So this is what we call a logical split of the data, and this is called split. So now over here, although my data, this was my block, but my split is something like this. So my split is, this is my split 1. Is split 1 and this is your split 2. And wait 1 minute. Sorry. And this is your split 2. So split is nothing but the logical division of the data, and your block is a physical division of the data. Does it make sense? What is a split and how the split is used by your MapReduce phase to get the logical data to logical data which can be processed? So your these two are overlapping because half of the data of this line would be read. Practically, this line would be something like this. So half of the data would be read and will be transferred to data node 1, and half of the data would be read and would be used in this reducer. So this is your splits. So these are the two splits. Split 1 is spanning across data node 1 and data node 2, but only a part of the data from data node 2 would be read and will be transferred to data node 1. And this is your split, your data split. So split is nothing but a logical division of your data. However, the blocks are your physical division of the data, which is stored into your real disk. So what happens? Any doubts? Any questions over here? Make sense to everyone?
Yes.
Okay. So you can just keep on pinging on the chat window, so that makes me sure that you are listening to me and I'm making some sense at least. So this now I hope everyone can understand the number of splits is equal to number of mappers. So for each record reader, there will be only one mapper instance which is created, and for each record which is read from the record reader, the mapper function of that same mapper instance is called again and again on that node. So for each split, there is one mapper, not for each block. However, in practically you can configure both the sizes of block and the split, but the default sizes of the block and the split in 1.x is 64 and 128 in your latest version. Now, if I make the split size as double as the block size, do you think I am gaining something or I am losing something?
Can you repeat the question again?
Okay, so my default split size in Hadoop 1.x is, and the block size, the default block size and split size in 1.x is 64 MB and 64 MB each. Now, if I increase my split size, so both of these things are again configurable. If I increase it to, will I achieve something in performance? Will I decrease something in performance? In what do you think? What this thing will do? So if I do something like this of configuration, what I'm doing is I'm transferring a lot of data across the network because the blocks would be segregated across data nodes. So each split is spanning at least two data nodes. There might be cases that both the blocks are lying on the same data node, but the probability would be less. So I'm just saying at least two data nodes. And with this, I am doing a lot of network. I'm basically doing a lot of network latency when I'm reading the data. Or the network cost which is added to my data processing. And I'm not doing the processing localization, the localization concept on which basically Hadoop is working. So I'm breaking that thing, and this will make my processing slower. So you have to precisely choose the split size and the block size when you are configuring your cluster, and there are different other things, but I'll talk about those things, how this will help and how you can change your split sizes or reduce the block sizes or increase the block sizes, and how those can help you in different file formats and compression. But I was just trying to give you one picture over here, right? Another case, say I made it 2, block size as 128 and split size 64. So do you think any benefit or disadvantage of doing this thing? We'll talk about these things in detail about in our next classes also, but I'm trying to give you a little picture right now.
So I think if the split size is larger than the block size, the performance will be slower.
Yes.
It should be relatively small because it is holding only the logical data. It's not holding the physical data.
Yes, and the number of splits is always equal to the number of mappers. So I'll talk about this thing when we'll talk about the containers and other thing. But your task tracker get initiated for each split, and inside a task tracker only one mapper would run. So that kind of JVM or your RAM is consumed by while running that your task tracker. So if more than one splits are created on a single block, you would be using more RAM on that data node. So now my question is, I also explained you half of the concept, but now again my question is, if say my block size is 128 and my split size is 64, what benefits you see, what disadvantages you would see? And should I do this or not?
I think you should, right?
In some of the cases, yeah, we can do it, but again, it will again depend on the process. So what I'll do is, when I can do this thing is, when I check my cluster and see my cluster memory utilization is very less. In that case, I can do this because in that case, I can create 2 simultaneous JVMs to process my data faster or parallelly on the same data node. But this will again add the booking activities, another thing which your job tracker need to do. So again, this might give you performance benefit. This might slow down all the things also for you. So you have to check those things, and based on the file formats and compression you are using, you again might see those things. Based on the CPU usage on the cluster, you again think of this thing, because again this will, as 2 different JVMs would be initiated, your CPU usage also would increase on your corresponding data nodes. So you have to check if your CPU is free more than 60% kind of things before doing all these configurations. So I'll talk about again. I'll talk about these things again when I'll discuss compression and file formats. Yeah, any questions?
So yeah, Miraj, I have one question. So assuming every configuration is same, the CPU utilization on both nodes. So what is the recommended approach? Split size so should be smaller than the block size.
Split size is always equivalent to a block size, equals to, but this is a default configuration also, and this is equal. But again, based on your cluster configuration, how your cluster is used, and if your cluster is idle on the CPU, if your cluster is idle on the memory. So based on those things, you will decide you might change these things.
Okay. Okay.
Right. So I'll talk about
and if you have enough memory and the CPU to change this, then it will increase the performance basically.
No, you can't guarantee that thing again. Because again, creating multiple JVM instances on your node would require a lot of bookkeeping activities by your job tracker and task tracker, by your job tracker. You have to tracker again 2 more JVMs, and those JVMs need to initiate it. So initiating a JVM itself is a time consuming thing. Then getting the heartbeat signals of that JVM, maintaining that on the job tracker again is a timekeeping thing. So these bookkeeping activities also take time and consume things for you. And not only the CPU, the time as well as the memory. So in some of the cases, you might see the bookkeeping activities are taking more time than the data processing for you. So again, based on your data, based on your requirements, you again might not think of increasing it or reducing it. So, but what is a split that makes sense to everyone right now? And For each split, one mapper. And in when I was talking about the task tracker and job tracker, I talked about these things that your job tracker finds out the number of splits and mapper is equivalent to number of splits. That is what I was saying over there. Your each split will spool one mapper, and for each record from your split, we pass this whole record to the mapper function, and mapper function will do all these things, and same mapper function will again be called for this record, and same mapper function will again be called for this record, and so on, and this mapper will keep on producing keys and values, something like this. Any other question over here before I switch back to the PPT? Anything on the split size again, block size again? Okay.
No.
Silence. Right. Sure. So let me switch back to the PPT. Okay. So this is how your basically data is read from your blocks. Splits are created, splits are used, and data is processed. Hey Rajesh. So this is what we are discussing right now. I think Rajesh, you can hear us. If you can't, just ping me on the chat window. We were just discussing about some of the concept of mapper and reducer, how your data is used and how you create, how the splits are created. If you want any discussion on that, we can do after the class. But I'll just continue for the sake of others. So your mappers are created, your mappers create produce key and value pairs that is used by the reducer. Now let's look into the sample map reduce program, what we discussed right now, and how that is used to process your data. So this is how your mapper looks like. Your mapper extends your mapper and there's a function called map, which is called for each record which we are discussing in the Excel sheet. So for each record, this map function will be called with the key as a byte offset value of that record and the value of that whole record, and context we'll talk in some time. And what you'll do is you will just ignore the key, but on the value side, what I'm doing is I'm just tokenizing the value and producing each word from the value. And for each word, what I'm doing is I'm producing word as a key and one as a value. And what is this interwritable? What is this text? I'll just talk about those things also in some time. And the reducer class, what I'm doing, so in the reducer, there's a function called reduce, which is called for your each key, each unique key. So, but, okay, so Umesh has one question. Let me read the thing. When the split is it across the two data nodes, how does the task tracker track? So, Umesh has a question. When the split is across two data nodes, how the task tracker tracks the task? So, Umesh, the split is equal. So, for each split, there is only one mapper which is created, and that mapper is nothing but your JVM instance. So, instance is created only once, and that instance, on that instance, I am calling this mapper function again. But to call this mapper function for the last record which are highlighted in the
Hey,
Excel
Miraj,
sheet. Yeah.
Miraj, you are breaking up.
No, I'm breaking up.
You are breaking up. Audio is going silent sometime, and then yeah.
I have cross-checked everything today in the morning. I have cross-checked with a demo video also. Again, it's breaking up. Interesting.
Hey, Miraj, can you hear me?
Yeah, I can hear you.
Okay, I had some issues with my audio today. So if you go back to the previous screen with the Excel spreadsheet,
Okay.
right, I was only seeing the,
I was explaining
I
it.
couldn't hear my audio. But
Yeah,
if you go back to the,
sure. Just a minute. Just a minute. So this is a screen.
It's not loading yet.
Yeah.
You only see.
Loaded?
Yeah, basically the one that you explained with apples and
Yeah.
banana. Yeah, here.
Yeah.
This
The
one.
split one actually is spawning between node 1, data node 1 and data node 2, right?
Yes. Yes.
So we have some, some samples of apples, oranges. Basically have intersect of those two data between nodes, between the blocks.
Mm-hmm.
So when the client comes in, you said like we split in across the data blocks
Mm-hmm.
because it's only one task, right? So how does it know when or how much how this split is completed? Because there are two data nodes. There should be two task trackers for each of the data nodes, right?
Mm-hmm.
How would it actually keep track of it is done or not?
Okay, I think good question. So what happens is your task tracker, there's one task tracker which is running over here. And there's one more task tracker which is running over here. Okay.
Right.
There's one task tracker over here and there's one task tracker over here. So this task tracker will start reading your data only from the logical start, which is nothing but this thing, and will ignore the data prior to this. But this task tracker will communicate with the name node and figure out what is the next block, because my data is not logically ended. And when it will communicate with the data node, it will find out that the next block is lying on data node 2. It will communicate with data node 2 and say, I want to read this data only till now. So this data would be read by this task tracker and will be not exactly by the task tracker, but your record readers, the reader classes which are there. So those classes will do all those things for you. But inside the JVM, which is pooled as a task tracker, and then the data it is basically passed to your mapper function. Make sense?
So basically, it's one instance of split one shared across two task trackers, right? Like in terms of like objects, if we talk, is that the way it is? Like the same instance of split is being across.
No. That's no. So here, his split is nothing. His split is just a logical data block. Logical data block, nothing else than that. Your real data or real thing is done by the JVM, which is running over here. So this is your JVM. This is,
yeah, because I missed the first part, I think, when you were explaining this thing. So I was just looking at the diagram and I was trying to understand that.
This is your JVM, which is created, and this is your JVM, and for inside this JVM, a mapper function is called again and again for each record.
Okay.
So,
okay.
Yeah.
Yeah, Miraj, I have a quick question.
Yeah.
So in this case, majority of the record is in block 1, the data node 1. So the remaining data from the second or whatever, the data node 2 will be moved to data node 1, right? For the first, that record, whatever is split. What if, for example, data node 1 had APP and the rest of the data is in the second node? Will that data record go to the second split, or will it still be read as a split one?
So basically what I'm saying is, this guy will not start reading from here. Ellie, the reason is it cannot find the logical start over here. This guy will start reading only from the logical start, which is Apple. If this guy starts reading APP, it will not find the logical end of this thing. So this logical end would be then used, or it might be the case that it never communicates to data node 2. It might communicate to data node X, where another copy of this data is lying. So it's not. So this is your data node 3, but it's a copy of this data. So this guy might communicate to data node 3 to get this data. So it's not now related to a task tracker while data is transferred, but the task tracker are just doing their task to process the data. And a split is just the logical division of the data.
Right. So my question was in terms of So whichever logical split has the starting of the record, that will get the remaining of the record. Is that what you're saying?
Yes.
Okay, got it. That's what my question was.
And here the split one is segregated over here and here, practically. It has not read from there. So this is your split one now. Instead of spanning to data node 3, it might span to data node 3 also. Data node 2, it might span to data node 3 also. Okay. So okay. Rajesh, I again cross check for you, but in my other two classes, I am not again here in this complaint. Not sure if there's some problem with the timing or what. I'll again cross check that thing today. But today in the morning, I did this testing before this class because last time we had this challenge. If it's major challenge, I'll do something else. But do let me know if it's a major challenge. Hearing it up.
No, I think you are fine. I mean, I can hear you okay.
Okay, so because in the other two batches which are running up in the morning, I did not hard this today again. So that's why again I was wondering. Okay, so this mapper is called again and again. So this your JVM will sorry, not JVM. Your record, this mapper function will be called for your each record, and this will be called till your logical end of the split is not achieved. And then the data is transferred to your reducer. In the reducer side, you will get a key, and that is your each word and iterable values. And what you will do is for each key, you will just sum of the values and produce the output, and you will get the word count. Make sense, everyone? Before I move on and show you the real program, and we will try to run it. Okay, so let's try to run it. Before that, there are a few more things. So these are the mapper and reducer, but there's something which really need to trigger it. So all this thing is done with your job conf. So what in the job conf, job conf is nothing but the configuration of job. So you do the configuration of the job and pass it to your Hadoop word, and then your Hadoop will basically read that logic. What I was shown in you in the previous classes, that logic is read and basically passed over basically run by your task tracker. And this logic, the copy of this logic is copied into your SDFS, but the replication factor of this is by default I think 8 or 10. However, the replication factor of the data in my cluster is by default 3. And I hope you can understand why the replication factor of your Hadoop jar which you put into your Hadoop cluster is so high. Everyone can guess that, right?
Yes.
Okay. So here what I'm doing is I'm just setting the job name, which is nothing, the word count. I am, okay, just ignore these things. I will talk about this thing in some time. I am setting my mapper and reducer class. So the mapper class is the map class which I gave to this. So this will be your word count mapper over here. And the reducer class will be your word count reducer over here. So those things I'll put over here, dot class. And ignore these two things for a time being. We'll talk about these things again in some time. And this is nothing but your input data which your mapper has to read, and the output directory where it has to produce the output. And I'm just say run it. Okay. So in the job, so I'm just configuring the things related to job and will trigger it. So let's try to look into the real program, Java program, and then we'll try to trigger it. So just give me a minute. Let me open my Eclipse and then I'll show it to you. Just give me a sec. Okay. Okay. So You can see my clips, right?
Yes.
Okay. So this is our mapper class. In the mapper class, we have to always have a map function which will take your key and the value which are string, and the context is the context of your uh, of your job, which is basically running up. So here we just tokenize the so over here what happens is everyone understands the serializable, what is serializable, serialization, and um, uh, uh, what for serialization is used for. Anyone understand that part?
Yes, yes, we do.
Okay. And I'm assuming yes from everyone else also. Okay. So if you don't, just ping me.
Yes.
If you don't, just ping me. So so basically, all of these things. Okay, just give me a sec. Let me show you one more slide before I go over there. So these are the default data types in the Hadoop. Everything is writable. So all of your keys and values need to be persisted, or they need to be transferred over the network. So everything need to be serializable. So all of the data types in the Hadoop are serializable, and they are prefixed with writable. So your Boolean is your Boolean writable in the Hadoop word, byte writable, double writable, float writable, int writable, long writable. Text is your kind of text, long strings, null writable, and you can definitely create your. So everything is configured in this word. You can create your own writables by just using this, and your keys are comparable as well. Again, you understand comparable and comparator kind of things. If not, just ping me right away. So, and can anyone tell me the reason why the keys need to be comparable? However, the values are not required to be comparable?
Because for sorting and shuffling, we need the keys to be compared, right?
Yes. So your keys has to not only be writable, but they have to be writable comparable. So your keys need to implement writable comparable, and your values has to be writable. So these are the different data types in the Hadoop world, and that is what we were looking in that program. So I'll again switch back over there, and we'll come to this in some time. So your so again the key which you are reading up that will that you can define over here. So this is a long writable because that was the bytes offset value of my record. So that is long. So I have used the key as a long writable. The value is the text because that was text. And over here on the value, what I did is I've converted it to string of Java string. And so text to Java string, Hadoop text to Java string, and Java string I tokenized to and produce the context.write. I'm writing this context.write will go to a reducer. And so I'm writing the word that is the tokenized string, and the one as a count. One is nothing but your int writable one. And similarly is my reducer over here. So here I'll get the iterable values as I told you. So I'm just doing, and one more thing, I'll again repeating that part. The key which is intended for a reducer will always go to the reducer. There will never be an phase or scenario where a part of the values belonging to one key has gone to reducer 1 and a part of the values belonging to the same key has gone to the reducer 2. Because this reducer again works on your hashing concept. So the reducer, which is a candidate of a particular hash key, that the keys will go to that corresponding reducer only. Let me explain that part again to you. I'm not sure whether I explained it in the previous class or not, but let me just rephrase what I'm saying. So say novel, just one more insert and novel. So say there are total 4 reducers or 2 reducers which are doing my whole job. So this reducer will be handling some keys from say 1 to 5,000, and this reducer is handling say keys from 5,000 is nothing but the hash value of the key, and say 1 million. So it will always be the case that if the apple has a key of apple hash code is say so apple hash code is say 13 and this is 501 and this is say 41. So orange will never go over here and orange will come over here only and apple will never come over here. And pulp will also never come over there. And there cannot be a case that part of apple came over here as 1, 1 and part of apple has gone over here. This will never happen. Something like this will never happen. Because each reducer is handling a bucket of keys. So what I was saying over here is, and that's the reason this code will work, because I am assured that the key which I am right now iterating all the values of that key are now with me. So what I'm doing is for each value I'm just summing it up and producing the key and the result, and this is producing the count of fruits in my text file. Right? And this is your real word count program which will trigger. So this is a real word count program. Here what this doing, this thing is doing, this is some Java arts related thing. I'll just explain it. Now I'm creating a job conf and I'm setting the job conf name. So there's nothing, I'm just setting it a name. I set it the reducer class, which was the reducer class I just showed to you, and the mapper class and the mapper class. This combiner we'll talk about in some time. What is combiner also? And the reducer class, I set the mapper class, set the reducer class. This was the combiner. Sorry, I'll talk about the combiner in some time. And the file input is the path which I'm taking from the arguments, and this is the input path which my program will read, and this is the output path where my program will produce an output, and this I'll talk about in some time. So let's try to run it. So this all code is shared. This Eclipse project is also shared with you. You are all to import this project. All you have to do is file, import, and Maven, existing Maven project, and click next, next, next. And there's one more non-Maven project also. If you want to use that, you can use it. But I'm using Maven one. And to run all of these programs, there's a hint after each program. You can either use directly this command and run it on your console if you don't remember what I ran. And this definitely, when you are running it up, please change your input and output directories, because this thing you might be using something else. So again, I explained in the previous class how to create a Maven jar out of it and how to place it on your cluster. So the same jar is lying over there. So I'll just use this. Over here, what I'm doing is these 4 lines I've written because some people are using the Maven version, some people are using the non-Maven version. So the people who are using the non-Maven version.
Miraj.
Yeah.
Miraj.
Yeah.
You are breaking up a little bit, so you have to talk slowly.
Okay. Okay. Sure. So these 4 lines, why I have placed over here is in the next meeting I'll try to share an audio number also, so that this problem will not occur. And again, I'll test or there's some problem at this particular time. Again, let me figure out some things because I tested it up. But okay, let me be a little slower. So these 4 lines, why I have placed over here is because some people are using the Maven version and some people are using the non-Maven version. So people who are using the Maven version are basically creating a runnable jar. So when they are creating a runnable jar, their mainface file basically have the main program, and that is directly triggered. So they don't have to give the main class to the jar as an input. But when I'm creating it from Maven, I'm not giving the main class or putting anything in the main fist. So I have to define what is my main class, which need to be triggered for this jar, because this jar will have all the other classes which are lying in my project. So these 2 guys, so these 3 lines are just ignoring those things if I'm using the main class or not. So let's move on to the map reduce word. So everyone can see my black screen?
Yes.
Yes, we can see.
Okay. So I'll just try to run this program. Give me a sec. I just plugging in a broadband cable also. If there was some issue with the Wi-Fi, those can be resolved. So this might get us disconnected for a second. By the time my Wi-Fi, my broadband will get a Wi-Fi. So
Miraj, you're not loud enough. Can you come closer to the speaker?
yeah, sure. So what I was saying is because someone was saying that again there are problems with the voice, so I'm just plugging in my broadband cable rather than using the Wi-Fi. So this might get disconnected for a sec. Okay, so this is a Hue UI. So what we'll do is we'll put in the input file into the Hadoop Word, and we'll use that file as a processing of doing my word count program. So let me show you the file which we'll be using up. So I was using something from here. Let me check if something is lying over here. Otherwise I'll use some other directory. So everyone can remember the Hadoop fs command.
Yes.
Okay. So let me check if there's something in this directory. Otherwise I'll put some file. Or if
Your voice is much better. Your voice is much better now.
Okay, so I think because I was connected right from the Wi-Fi. Okay, I've used the broadband cable. Whatever, Hadoop fs minus. Okay, this directory does not exist. Not a problem. Let me check what is the directory. So I'm just trying to figure out any file which I can give as input. So and one more thing which you have to remember is the output path which you'll be giving as an input to a program, that directory should never be existing. And can anyone tell me what is the reason behind that?
Because if the directory is already there, it will just create a new directory. It will overwrite it. Right?
Yeah, it will try to overwrite it, but the problem is if it's overwritten, you're losing the previous data which is lying over there. And MapReduce assume that previously also you ran some big program or big task or something like that. And if you delete that data, you're losing something. So practically this should not happen. So each time you have to delete the output directory. So Hadoop fs minus rm minus skip. The skip trash is nothing but I am skipping it to move to bin. I'm just hard deleting it, shift and delete kind of thing. And
RM minus FR?
RM minus RF, yeah. Or maybe similar.
oh sorry,
RM diff.
minus RM minus RM नहीं उठा यार. No such file order. It's deleted. No, sorry. Okay, it's RMR. Sorry. It's RMR. And R is small. Okay.
Oh,
So,
RM space minus R.
RMR you can use it, or you can RM minus R also. That is what I was giving, I think, previously, but R is small. I forgot that.
Okay.
So let's use this file. Let me do Hadoop fs minus tail. Let me look into this file before giving it as an input. What a line over here. Nothing. A small, very small file. Okay, yeah, we'll just create a small file. It will just take a minute for us. So 120. So rather than using that console, I'll just use the UI. And we'll create a file over there that will just take a minute for us, and we'll use the file. So that this is where your UI comes in picture and is basically handy for you, because otherwise if I create a file in Unix and then move that to Hadoop Word, that will take time to me. Here I can create a file directly into your HDFS. This one file, right? MapReduce, there would be some file. Yeah, there are a lot of files. I was wondering where's the file. So here are a lot of files. We'll use this. So we'll use this text.txt, and let's look into this file. This file would have some text, definitely. Yeah. Okay. So there's a lot of text in this file. We'll use this file. So the command is Hadoop jar, your jar name, and let me go to the directory where the jar is lying. CD. So here is the Hadoop jar MapReduce and your main class name. So I'll just copy the main class name. This is your main class name which I want to give, and after that I'll just give the input directory and output directory. So my input is this, and I'll and the output. So now it will do all those things. If you can recall, it will do all those things. It has figured out number of splits. It's 1 because this is a very small file. So there will be only one mapper which will be created up. Running the job, this is job ID. And what is application? Application manager we'll talk about when we'll talk about Yarn, and I think probably next week. So we will also talk about the upper mode. What is upper mode? I started the mapper and the reducer. So everything is done. Let's look into the file. Hadoop fs minus ls, and what was the output directory? So always when your reducer runs up, the files are created something like this, part 00 something. So this will always be the prefix in a file name which is produced by a reducer. And the 000 is a reducer count. So if there were more than one reducer, the next file would have been one. If there were 3 reducers, there would be 3 files: 000, 0001, 0002. So if there's only one file, you can always safely do star and T. paste. fs minus output.
It has to be individual file, correct? I mean,
Yeah, but I think we can give it we can give it tail also, because there's a single file over there. It will automatically pick that file only.
oh, I see. Okay.
So see, your data is there, and there's one thing which you can see in the data. What is that? There's a word and the corresponding count, but there's one more thing which you can see in the data. Your words are sorted. Your words are sorted. Case sensitive also, so case sensitive are sorted also, but your words are sorted. And the reason is in between sort and suffer phase. Your keys are sorted, and that resulted your data is sorted because your word itself was a key.
So what is the first number? What is the second number? I think is the first one is the key and the second is the result.
This is the key and the result. So your now was appearing 2 times in the whole file. Off was appearing 4 times in the whole file. Original was appearing one time in the whole file. Page dot is taken as a single word because we have not removed all those things. So that was appearing once in the file and so on.
So what is the second number?
This is the value. How many times this number was appearing up? That is what we counted, right? Apple 1, orange 1.
Yeah, there are just 2 columns, Umesh.
Okay. So it's basically the same number, but it's actually kind of like tabbed, I think, right? So
Tabbed. Yeah. Key. Okay. So by default, your keys and value separator in the Hadoop word is tabbed, and the record separator is /n until and unless specified. So this will be assumption and all the technology which will be looking into this. So the default one is always your tab for keys and values, and for records it's /n. That is new line. So here each key and value pair is one record, and the new line is your separator for that key and value pair. That is what you can see over in the output also. So anything over here on the sample program before we move ahead? Okay.
On the Maven, I think you actually said Maven MVN install, right? To build the jar.
Yeah. So for that, what you have to do is you have to just go to command prompt, and I have to check where the directory. Just give me a sec. Let me open it and let me check where the directory. What you have to do is there's a file called pom.xml. Pom.xml. This file is containing all your Maven related thing. How your Maven need to build it. So all you have to do is mvn clean install. The first time it will do a lot of download for you. It might take 10-15 minutes, even more than that, based on your network speed and things like that.
Hey, Miraj, are you showing your screen? Because you don't see anything.
You don't see anything.
Yeah, I paused it. I was trying to find out the directory where the code is lying. So what you have to do is this file called pom.xml, and pom.xml will contain all your Maven related things. So in the directory where you have downloaded the code, at the root level of the directory there is something called pom.xml. So in the directory you have to just go and type a command called Maven clean install. At the first time it might take 15-20 minutes, even more than that, as it will download all the dependent jars for you. But next time it will not download, it will just do the compilation and build of it.
And this produces a jar file, and then we can use that in the
and the jar file will be produced inside a folder called target. So it will, right now I have given 2 dependencies in my pom.xml. So it will create with 2 jars. So one is with including all the dependencies, which will be a very big jar, and one is without your dependencies, which will be a very small jar. And this is what I have used in running the current MapReduce program. Okay, so this is what we did right now. So what is writable? I just explained you 5 minutes back. Anything which can be serialized is writable in Hadoop. So there's a writable interface which need to be implemented for that, and all your keys need to be writable as well as comparable. And comparable is same Java thing. So these are the things which we just now discussed up. These are different data types available over here, and you can always create a whatever we'll be looking up in Hadoop, you can definitely create. Everything is customizable. All you have to do is just implement those corresponding interfaces or the classes, and you can create your own or change the things. So if you want to go deeper into this, everything is configurable in this world. So comparable, I just talked about. Input split size, we have already talked about. Which is logical division of your records, and so this is how it happens at the back end. This is your input file which is divided into your blocks. So these are your blocks, somewhere here kind of thing, and these blocks are divided logically with the help of input splits. There's a class called record reader which basically reads your data from the input split record by record, which I was mentioning in the Excel sheet, and that record reader passes on each record to your mapper function. There is a map function of the mapper, and the map function of the mapper is triggered on each record of your split. So this is how everything happens at the back end. And there's something called record reader in between which does everything for you, which reads your real data, and that has created the keys and value pairs which will input your mapper class.
So who creates the splits? Is it the record reader or is it some other in between process?
So your splits are not created. Splits are decided only on the logical division of the data. So when the record reader will try to read your data, it will see that your data.
I see, okay.
Yeah, it will.
Okay, got it. Okay, got it.
Okay. So I'll just come to this part. Let me show you a few things. So you know this record reader basically there are different input formats which are used by your readers to read the data. So these are the few already implemented input formats which are used by a record reader to read your data, and you can definitely create your own, and same way you can also change the record readers also. I'll show you some of these codes. The text input format is the default one which is used to read your data, and this is what I was showing you in the Excel also. So this text input format will create your keys and value pairs, and key will always be your wrong writable which will be created by this class, and the value will be text, and key is your byte offset value which I was talking in the Excel sheet. So this is the text input format is the default one which is used to read your data if you don't define the input format which need to be used to read your data. This is the default one, and the corresponding record reader also get initiated which is corresponding to this input format. But everything is configurable in this part, as I was keep on saying. So you can also create your own input formats also, but there are other input formats which are already implemented for you. There's something called key value text input format. What it does is you have to define a property for this class, that what is a separator in your to create your keys and values. So say I said the default. If I don't define this property, the default one is taken care of as a /t. As I told you, default of each key and value separator in the Hadoop word is /t. So if I don't define this property, the default one /t is taken care of. But what will happen is, so say if my data is something like this. Say if my data is something like this, 1,90, 2,180, 3,900, and I say my split this key value separator.in.input light property is comma. So in that case, my key will become 1 and value will become 90. Key will become 2, value will become 800, and so on. So this is a separator which is used to define your keys and value separator. So you can create keys and values out of your data also. by using this key value text input format. Sequence input file. So there are different file formats which are there in the Hadoop world. Sequence file format is highly used in the Hadoop world. For a time being, just assume there's a file format which is other than text file format, and this is an input file format which helps you to read the sequence files. What the sequence files are there, how the data is stored into sequence files, we'll look into this thing in detail when we'll look into the file formats, different file formats supported in the Hadoop world. So this file input format which you will be using up to read the data from those sequence files. And similarly, there's one more thing which is called n-line input format, as the name suggests. So here each split is guaranteed to have exactly n lines. So if the lines are exceeded by n, a new split is created for you. So these are the few default input file formats which are there for you, and you can use it. I'll again go back to Java code and then we'll show you what I was showing you at that time, which I skipped. So here I have not defined it. The default one is taken over here, but I could have defined it over here also. So job.set input format class, and here I can set the class, any of those classes. Key value. What is that? Key value text, key value line. Key value text input format dot class, and this will be used. So these things we can define over here, and this is how we can change the job settings. I'll show you an example of those things also in some time. So these are the default input file formats and their corresponding record readers which will be using these input file formats. So the record reader which are corresponding to those input file formats are line record reader to for your text input format, key value record reader for your key value text input format, and custom record readers. Again, you can create your own record readers, and you can even create your own key value input, file input formats also. So for that you have to just implement the record reader, and you can create your own record reader also. So this is what we looked into the mapper class 5-10 minutes back. Your mapper has something called map function which takes your key in and your value in, and setup is basically used. You can create a function setup to set up the things. So it's almost similar to all what you do in either, if you have used struts or Spring, the same function names or things are similar to that. Setup, context, run. So all these things are similar to that. Cleanup is to clean your task once everything is done. Mapper. So if I don't have to create my own mapper class, I can use some of the default mappers which are already implemented for me. Identity mapper is nothing but it produces the key and value pair which is given to it. So it will not do anything on your data. Inverse mapper, as the name suggests, it will just reverse your keys and value pairs. Regex mapper will basically generate anyone has any question? Okay, I'll just put you on mute then. So regex mapper will generate your, based on the regex expression which you have defined while creating this, it will generate the match comma count. And similarly, the token mappers are used to generate your token and the corresponding count. So again, let me show you a code example for this. These things. So this is an example for using the different input format. here I've used the set input format class as key value text input format, and I have set the separator as a comma. And so in this case, your data keys and values will be generated from your data itself, and then I will be doing something on my data. So what I'm doing, my reducer. So these two classes are inner classes of this main class. So I'm not doing anything great in my reducer as well as in the mapper. I'm just producing the output of the mapper as it is, and producing the output of the reducer one by one as keys and values. Is it making sense, or I am going too fast, or do you want me to go a little slower? If you want me to go deeper somewhere or anything, do let me know. You can just ping yes or no in the chat window. That will help me. Okay. Karthik says yes. Rajesh, Umesh, Basha. Okay, Basha also says yes. Sumesh also says yes. Okay, cool. Thanks. So in this example, what I'm doing is on the mapper, I am just producing the keys and values as it is. On the reducer, for each value, I am producing key and value pairs separately. So because the values are in the list, what I'm doing is rather than producing key comma values, pair of values, I am producing key and value one by one. And I have used my, where's it gone? Key value text input format and separate as comma. So let's try to run it and see how the output comes up. So I'll directly use this thing, and I'll just cross check if these things are lying or not. So I'll just cross check if this is the correct directory or the directory is changed. Key value input format, yeah. So I'll just choose the map. So over here. Yeah, and we'll just delete this directory. So let's try to run it. Okay, output is not given fully, but it will trigger it. So let me open the file by the time it's running up. So can anyone tell me what will be the output of this program? This is the input to this program. Could you send me on the chat window what is the output of this program? What would be the output of this program? The correct output. By the time it's running up, just guess what is the output. Sorted, as well as there's one more thing which will happen with the data. So Karthik, if you try to find out and give the correct thing. Sorted, of course, yes, I buy a point. No, Vasha, not grouped, because in the reducer as I told you, in the reducer I placed the for loop on the values and I was emitting keys and values only. So not grouped. So although the data was grouped through the reducer, but in the reducer I added my own logic to ungroup it again.
So the key and value will be reversed first and then it will be sorted.
Not reversed. The class which I've used is, let me again tell you. So, where's it gone? So the class which I've used is key value text input format, where I've defined anything and the separator as a comma. So anything prior comma is my key and anything after comma is my value. So this is the input to your mapper phase. So a mapper input is, hello as a key and key val as a value. ABC as a key, text as a value. If you remember over here, what I did is key value text input format as your input format. And the separator to define your key and value is comma.
Yeah, it will be tab separated, sorry.
Yes, it would be tab separated as well as, yeah, it will be tab separated as well as sorted. So let's look if the output directory is created. Still to be created. Oh, what an error. What is the error? Input part does not exist. User hue, okay, I gave the wrong input part.
It should be map reduced instead of.
Yeah, I gave it wrong. I think to explain it to someone, I changed it, and after that I could not rename the folder. The output directory is not created, right? Otherwise, it will again give an error. Yeah. So practically the data would be, let me tell you the output. It will take some time to run. The data would be sorted on the key and the values would be tab separated. So ABC, tab text, and so on so. So let it run at the back end. Let's look into some other things. So make sense what is the file input format and how it helps you to read the data in different fashion. And you can definitely create your own. And similarly, you can create your record readers also. And you can use your default mappers also. So over here, what I could have done is, can anyone tell me how I could have saved a few lines in this whole code by doing what? If you look in the slide, you can think of one thing which I could have done in that program, and I could have saved few lines not to write them. I could have used this identity mapper, and this identity mapper, what it does is it just produces an output directly to the output, and this is what I'm doing in my mapper. So instead of writing this whole mapper class, I could have done something like this. My mapper is identity mapper. Identity mapper. This is what I could have done and used that mapper. So this is how these things, these different classes would be helpful to you when you are really running your own programs, and definitely you will be creating your own lot of classes also based on your requirements. But if you are really dealing in the Hadoop world, the probability of using the MapReduce would be too less, because these days Hive and Pig are used highly in the industry, and these are two technologies which will at the back end create the MapReduce code for you, and very easier to learn, very easier to write, and you don't have to write such 80 line of program to do such kind of things. These things you can do in a single line with Pig and Hive. We'll talk about those things, but you need to understand the concepts. So let's look into the reducers. So same thing happens in the reducer also. You have your the reduce function in the reducer class, and that reduce function again takes a key and the value, and please ensure the key type of this reducer is same with your output of the mapper, otherwise you will get an error. And similarly, the type of these values is similar to what has been produced from the mapper. And your values are writable, keys are writable comparable. So similar to your record reader, there is something called record writer. What it does is it writes your record which are produced as an output from a reducer reduce function, and that is dumped into your SDFS. Okay, so I forgot to tell you a few more things that record me over here because the writing thing came over here. The data. So where do you think the output of the, so what happens in the mapper phase? As I was telling you, there's something called sort and shuffle phase. So the sorting and shuffling kind of thing happens on the mapper node only before the data is really moved to the intended reducer. So the output of the mapper is spilled to the disk also. So where do you think that output would be stored? Does it stored in SDFS? Does it stored only on the local node? Basha says SDFS. Just guess. Just ping me on the chat window. What do you guess? Let's discuss about that thing. So Basha said SDFS. So what about others? The guess, it would be stored on the local file system or on SDFS. Just a guess.
The output of the reducer will be on the SDFS.
I'm talking about the mapper right now. The mapper output is stored on the mapper node and then passed on to reducer. Some of the data might be spilled out to disk also. So
right. So the mapper's output is local.
Yes. And the reason is?
It's a throwaway data. It's not going to be persisted forever. So it's not going to be in the SDFS. It's local, and then it will get wiped out when it's processed.
It's local, I buy your point. It's throwaway data, I buy your point. But to
reduce the network bandwidth.
Yeah, the overhead to put into SDFS is too high, and that does not make any sense over here because the data is just a throwaway data. Yes. So a mapper output is written on the disk and on the local disk if that is spelled out, and your reducer output is always written on the SDFS. So similar to the mappers, there are reducers also. Identity reducer, as the name suggests, this does outputs what is the input to the reducer. Long sum reducer is nothing but what we did in the previous program, what I showed to you, it is summing up the values for each mapper. So what we did in the word count one. Then similar to your input format, there are output formats also. Text output format, again similar to your input format, it writes your keys and values by tab separated, and this is a default one which is used if you have not defined any text output format in your job call. And that is the reason when we ran the previous program, we saw the keys and values were tab separated. Sequence file output format used to create your sequence files. What are sequence files? We'll talk about those things.
Just a minor correction in your presentation that tab is supposed to be /t, not /t.
Yeah. I am always, yeah. So thanks for that. Null output format I never use this class, but there's a class which exists. I don't know, but sometime you might use it. So it will basically, suppress the output of the reducer and nothing will produce out. So I'm not sure what it's used for, but this class exists. Okay. So before we look into some advanced feature of MapReduce, any questions on this mapper reducer input format, output format? So what we'll do is just a minute, Umesh. Just a sec. So what we'll do is rather than moving into advanced MapReduce, we'll look into the problem if you have faced anything and installing your whole cluster, importing the program, and let's try to run one sample MapReduce on your PC before we move ahead. That is what I'll suggest. Then I'll leave it to you. So Umesh, you were saying something.
Yeah, so in the samples that you have, this should have, we saw the text output formatter sample. We also see key value pair output formatter. So is there like samples that you can have, like there's some Java docs or things, some things from the for these guys, for other ones who use it?
Java doc I don't have, but if you require, I can share you some PDF of the book which talks about these things that I can share you. I don't have exactly Java docs which talks about in detail about these things. Java docs are all open source. You can directly look into the web. So Java docs I don't have, but I can share a book which can give you insight about the technicalities. Yeah.
Some kind of a sample that I can refer to for different patterns.
Oh, okay. Okay. So few examples are there over in my code also. If you look, some examples you might see, like I shown you this. There might be some input partitioners, custom writable. So here I'm creating a new writable. Input for so there's a custom input format which I'm creating over there. So some you will find, but not everything. Yeah. So I'll share you the link to Java docs where you can find all the Java docs for this. I'll share the link for you. It's everything is open.
Sure, thank you. Yeah, and yeah, I think you had some question answer session for installing the VMware and things like that too, right?
Yeah.
I had some issue.
Yeah.
So is it a good time to talk?
Yes. I was coming to that part only. So rather than moving to advanced MapReduce, let's talk about any problem which you face and also try to run a sample MapReduce at least so that you have your environment ready. So yeah, definitely you can talk about that thing.
Okay. Because I had tried to install the Hortonworks on two laptops. One is my own laptop, which is HP, and it's HP Latitude, and the other one I also tried to install on my office laptop, Lenovo IBM ThinkPad. In Lenovo, it's basically saying the virtualization is not enabled.
Okay.
Right?
Yeah.
And I looked at the documentation that you say to go to the BIOS to enable it. Right? I tried to do like different like there are options that actually puts like F1 and Alt F4, Nothing seems to be working on my laptop. It's like I tried to put F1 on when the server starts up. Do you know how
Okay,
can I
so
get to the BIOS?
Umesh, what I do is, or the best way is, so as soon as you press the power button, rather than pressing F1, F2 or something, you just drag your whole, 5 fingers on all the F keys. So at least one works and
That's
takes
what
you
I
the
did.
Wi-Fi.
Like
Okay.
I tried to do like all the yeah. I think something wrong with because the way it is set up. Maybe I'm not. I don't know. You know, like
If there's a company if that's a company laptop, yeah, the BIOS might have
that
been
might be
disabled for
exposed,
you.
right?
Yeah, that might have been
Right.
yeah.
Right.
Umesh,
Because
if it is Lenovo, I think F12 or F2 will work.
I tried like almost all the keys, but I'll try again F12 and F2.
Yeah,
But
and you have to keep
maybe
it
they are
pressed.
disabled.
You have to
And
keep it pressed.
Okay, I will try that again because
and Umesh,
you also installed in company laptop, right? Karthik?
Sorry, what is it?
You installed in the company's Oracle's laptop, right? Like in
Yeah, but mine is a Toshiba.
Toshiba. Okay.
and Umesh,
This is a new laptop I got. Yeah, go ahead.
I have also shared one software over there only that talks if the BIOS is disabled for you, you can directly check it rather than going to the BIOS. Just install that software and that will show it to you if the virtualization is disabled in your BIOS.
Yeah, it is disabled. I can
Okay.
yeah,
Okay.
I saw that setup PXE. I installed it.
Okay.
That's how
Okay.
I know that virtualization was disabled.
Okay. So you
That's
have
why I was
to.
trying to go into the BIOS to enable it.
Mm,
Yeah.
so that you have to do. I can't help
And
you.
in the
Yeah.
HP, I got saying that the kernel is not supported. It says
Okay, so your
uh,
laptop might be, pretty old. The laptop's too old at the time. The kernel did not support it virtualization, so your laptop might be very, very old.
no, not yeah, it's not that old, but it's not new also.
Sorry,
This is HP Latitude. So I think I'll try to
Latitude.
figure out.
Latitude might be, I think, 2007-8 series, right?
I don't know when we bought that, but yeah, I think it's not recent. It's
If
basically a
it's
couple of
if it's
years.
older than 7, 4 or 5, I think those had the virtualization disabled, but the newer ones do not have all the BIOSes have the virtualization enabled in them. That
Okay,
might be
I'll try to
not the
figure out
BIOS
if.
part, but the kernel supports them basically.
Mhm. Yeah, I'll try to figure it out, but yeah, I'm kind of like stuck in installing that, enabling the virtualization there. That's why I'll try to figure out this week.
Sure, sure. Anyone has any other issues while installing or starting up the VM?
Oh, I have not tried, Viraj. I
Okay.
was under the impression that we'll go through that exercise today.
So yeah,
So
so that's the reason
we didn't try.
so that's the
Okay,
reason
that's fine. I will set up the environment maybe today or in a couple of days and try it out.
Okay, sure. So, do you people want to try a MapReduce program before going ahead?
No, we don't have except for Karthik, nobody has the environment set up, so I don't think we can run the program.
So, okay, Marsha did not
Maybe we
try
can
it.
do that next week we can do that, but for now, for today, let's continue with the presentation.
Instead of next week, why can't we do it tomorrow?
Oh yeah, tomorrow we can do. Yeah, tomorrow.
Okay. So, anyone else is facing any issue like Umesh was facing with starting up the things? Okay, Basha did not try. Karthik already had it. Umesh was facing issue. Rajesh? Okay, sure. And any issues while importing the code or anything? Okay, although I've shared it today only. Sorry for the delay. I really forgot that. If you are facing anything with importing the code or anything like that, do let me know. So, okay. So then, okay, then let's
Hey,
go ahead. Yeah.
quick question, Miraj. So when you import the entire code directory, or you import only the MapReduce?
No, the MapReduce. Okay, so in the drive you will see something like this. In the drive there's a folder called code. They had two folders. One is with Maven, without Maven. If you are going to Maven, just file, import, and
So no. What I'm asking is there is a code.zip, right, which has the entire code directory. So within that, we want to only import the MapReduce project.
You can import everything because I have some UDF from Hive Pig also over here, so that we can discuss in the Hive class and Pig class. So these are the UDF which I've created. So you just import everything, and that is more useful. It might have the static code which we might see in the other classes like streaming and things like that. So all the code is now you can, although this is not related to Java, but this will help you to have everything under the one window. That I have that just creates it like this.
Okay.
Okay. So okay. So okay, sure. Then let's move into some other things rather than in the tomorrow's class. Then we'll try to do some try to run some MapReduce and try to write some other MapReduce code. And so let's look into some other features of MapReduce thing today.
So Miraj, before I think we move on, remember like last time I was saying everything is a key value pair, and we cannot reduce that into a key value pair kind of like concept. So I think like okay, if I know the data distribution in the data nodes, I can actually derive an equation with the key value pair, right? Let's say you talked about apples, you talked about colors, and you basically if you know what is the factor in which the data is basically distributed across the data node, then you can come up with a very good theory of the key value pair distribution, and then you can get the value for the search, right? But in a real world scenario, how does that work? Because let's say Google is trying to do something, right? You have a big data warehouse and things like that. How does it map into the key value pair?
So Umesh, one thing, you don't have to worry about how your data is distributed across data nodes. So that is automatically taken care of. All you have to do is do some processing on the data. So that some processing has some logic which need to be implemented on that data. You have to just divide that algorithm of applying that logic into two steps. One is a mapper phase and one is a reducer phase. Let's say, let's look into some real world examples. This might require you some file format structure or something. I'll talk about those things. But if those sound Greek to you, don't worry. We'll talk about those things in some other class. Let's say 5 months or 6 months down the line, there was an Airtel marathon over here in Delhi. I ran into the marathon. There were more than 10,000 people in the marathon. Photographers were standing on top of big poles, and they were just clicking people who were running. And each person has pasted that number, his unique number on his t-shirt that was mandatory for people to run. So everyone has pasted that in front of their on top of their t-shirt in front of their chest. So these photographers were just clicking on the photos of each one who was running, and 10 days after I ran the marathon, I got an email into my mailbox that says if you want to get a photos, click on this link. And when I clicked on that link showed me 3 perfect photos of mine. And I hope you can understand what happened in the backend. They process millions of photos. Based on that photo, they do some image processing, figured out the number which was written in the image. Based on that number, they figured out this is related to this mail, this user, and they triggered a mail. And if you want to print or get that photos, you pay it and get it. So the scenario is big data scenario. Agree to that part, right?
Yeah, but who processes those data?
Yeah,
because somebody has to process.
So somebody has to process the data. So what happens at the back end is all the photos are placed into a SDFS. Okay.
Right, because I think, okay, because
Ah,
it starts in a problem statement, right? Your
yeah.
problem statement was to find all the information of the a marathon runner
E-
based on their number in their tag and associate that with their photos and the email
That's
ID
what.
and things like that.
Yes. And mint money somehow,
But
somehow on my data I want to mint money. Everywhere the problem statement
right,
is I have to mint money. Yeah.
right,
So what happens at the backend is, say I store those photos in a file called sequence file. So sequence files are kind of placeholders to place your these kind of data. I'll talk about that in detail, but these files are kind of container which can put your smaller data. Now what will happen is in the mapper phase I'll just read the data as it is. So my key would be any random key, but my data is my whole image. In the mapper phase, I'll process my image and will try to figure out the number written on the image. So the algorithm which will run in the mapper phase, which will find out the number written in the image. If there is no number, I'll just ignore that key and variable that is junk to me.
so but every entity like your image or email and it's all tied to your number. That's why you can actually do a mapper.
Number or anything, you have to create some key which is unique to your data. Because you want to do something on the data, you have to figure out something unique in the data, and on such a big amount of data, you want to just find out something peculiar, something which is useful to you.
Right. I think that basically that defines the whole thing, right? Because you are defining the problem statement based on some entities, and you are trying to search based on that. Right? That's how you can actually reduce it to map and key and
Yeah.
value pair.
Yeah, you can think of any other scenario. We can try to resolve it. Think of any other scenario. Let's try to take it right now. Which you think cannot be solved.
Uh,
But that should be
I
a big
think, you know,
that should be a big
take
data
a problem
problem.
statement.
Yeah.
If you take, yeah, if you take a problem statement of any kind, like for example, hospital, patient, and laboratory, and all those things, right?
Mm-hmm.
So yeah, if you take based on a key and a value, if you divide the data in a key and a value pair, then I think it's actually much better. That's for example, I am trying to understand how Google does search, right? Like Google actually goes and search for.
Again, your data is indexed, and your index is used to give you faster results.
Yeah, you don't have access to any of those data centers and things like that, let's say, right? So basically you have some requirements to have this Hadoop thing to work, right? Basically you need to have the business knowledge of what you're trying to do, right? And you basically have to access to all the data that you want to accumulate. And then you store that in the HDFS, and then you actually come up with some algorithm to how do you do the map and reduce based on some criteria that you want to search. Is that
Yeah, definitely you have to have the access of the data, and you have to get in the data into a Hadoop world. So that is the first bare minimum requirement before you start any processing on the data. So, and the algorithm logic can be written in anything like hive, big, map, reduce, anything, and that logic will trigger in the Hadoop world with the help of your job tracker and task tracker, which will do a parallel processing on data. So you don't have to worry about the scale of the data which you have. Your data could be processed in very fast manner and in very short span of time. And if you want to increase or reduce the processing time further, you just add the data nodes and your data your processing time could be reduced. So think of if I have to the example I just took, if I have to figure out the image and send those emails in my Oracle Word or somewhere in the traditional databases, I would have stored those images, and to process that image or on such a big volume of images, what kind of, you can think of the Oracle on simple small tables, 2 GB tables or 10-15 GB tables in a normal relational databases. If you have to search something on those tables, your query will die. You have to reindex those tables prior you search those things. And if your data is not
yeah,
indexed on those parameters,
I see the potential. I think when as a big Teradata and things like that, it definitely is helpful. But I think you have to understand the pattern of the data before you come up with this query and things like that too. Right? That's I think the main key. I think. Yeah.
yeah. So there are two things which you are talking about. One is the business logic, and one is the processing related thing. What big data is helping you to do the batch processing of your data. What logic you want to apply, that's your business logic.
Right. Yeah, I think I.
Yeah. Hi, Miraj.
Hi.
Just one question.
Yeah.
So I installed this sandbox, but I think I'm running into the same problem as Umesh. It says when I try to start it, it says
Virtualization disabled.
VTX is disabled in the BIOS.
So, Basha, in the document itself, installation document, I've defined in detail. You have to go to BIOS and do the changes to enable the virtualization. So you have to just go to the BIOS.
So is it in the document?
Yeah, inside the installation document, yeah.
Oh yeah. Okay. I will try that. This is I'm using the Lenovo ThinkPad Office laptop.
Yeah, I think if you can actually get that BIOS screen up and running, let me know, because I have been trying it like yesterday. I have like Lenovo i5 4300.
Same thing. Yeah, same thing here.
Okay.
So I'm getting this the same VTX is disabled, so I'm trying to figure out how to fix it.
So I am not sure. Are you all people from the same office? Because in my previous batch also from US Oracle, there were 2-3 students, and none of those reported me this error. So, but they were not from Texas. They were in EST time zone, so they were definitely from some other state, some other state.
Yeah, they're probably from California.
No, but anywhere I think they'll be all getting it from the same department of all the laptops of issues.
But they did not told me this problem.
Yeah, I think there is. Yeah.
I don't know.
Even Karthik don't have the problem, so I think there is something specific to this i5 4300. We have to check it out.
Yeah, but you have to just check. There's a simple flag in the BIOS. Just enable it. That is the thing. But you have to reach BIOS. Yes.
Yeah, I saw your document. It's a simple flipping of disable to enable. But to get to the state of the screen, I'm having some issue with the laptop here.
Okay. So, any other question? Anything before I go ahead?
So you mentioned about a box like sort and shuffle last
okay.
week, right?
Okay, let me explain you.
We didn't go.
Sure.
With that layer today.
So actually, short and shuffle in detail I covered in the advanced concepts of Hadoop, which is not in the basic. But as you've raised this question, let me explain you how the short and shuffle happens. Actually, going into those things sometimes confuse the people also, and I covered in the advanced Hadoop. So what happens is your mapper output. You can see my Excel sheet, right?
Yeah, we can see.
Right. Your mapper output is there's something called a kind of round memory, which is nothing but your kind of RAM. So mapper output is split into your RAM. So keys and values are kept on storing over here, something like this. I am just making it red, so that looks like it's storing something. And green one is empty. So mapper output is placed into this memory, but there is a limit to this memory, how much data it can store. As soon as the data increases in this memory, the data is spilled onto the disk. So this is where your spill happens to the disk. So before spilling out the data to the disk, the data is really partitioned based on the keys and sorted before it spilled to the disk. So this is your first phase of a short and shuffle phase, and this partition data is then reaches your reducer. So say over here, this is a mapper, this is our whole mapper class. This is a whole mapper box, and this is your reducer box on which reducer is running. Okay. On the reducer side, the data which is intended for this reducer reaches up, and so the data from n number of mappers will come up. Mapper 1, mapper 2, mapper 3 kind of thing comes up, and key and the corresponding values, and so on. So prior the data is really given to the reducer, this data is again combined for each keys, and as this data is already sorted up, so it's very easy for combine the different keys, and before this data is given to the reducer, this all the similar keys are merged and on the reducer node before this data is really given to the reducer. And this, I think, also answers one of the questions which I think Umesh says in the last class, how the job tracker tackles the sort and suffer. So practically this is happening either on the mapper on the reducer node only. So this is how everything is tackled in the JVMs where your mapper and reducer are running up. So there's nothing new which is triggered in this case. And the mapper output is spilled to the disk, and while a mapper output is spilled to the disk, this output is sorted prior to spilling to the disk, and also partitioned based on your hash keys of the hash values of the keys. So this is happening at which is transparent to you in the short and suffer phase.
Okay. So basically, the short and shuffle phase is basically to do the output of the mapper to sort it and schedule it for the reducer.
Yes.
Is that right?
Yes, and before the data is really transferred to the network, this bit is really sorted up, and the reducer might get the data from different nodes or different mappers, and this data is combined prior giving it to the real reducer function.
Okay.
And this is your map function outputting this data.
So can we see that? I think you mentioned about you actually run a couple of programs now, like the test thing. Is there a way we can actually go into the view and look at what actually happened? Like.
Yeah, sure. So let me show you that part also. That will not make very great sense to you before I tell you the application and other things. But basically, before I tell you the yarn concept, but let me show you that part. Oh, sorry, not job designer, the browser. So it's a job browser where you can browse the jobs which were ran for you. And so these are two jobs which we ran just now are visible to me: word count and the file input format value key. So this is a container which it ran. What is container? We'll talk about those things in the yarn class. These are two tasks which ran: a mapper and the reducer. So let me show you. Gone blank. Okay, let me. Okay, just a minute. Let me share the Chrome.
I couldn't hear. We could.
Can you see me now?
Yeah, I can see the recent task.
I can see the Hue browser. Yeah.
Okay. Fair enough.
Yeah, the browser is fine. I think the voice was kind of like blank.
I'll again get his cross-checked. What is the problem with this? What is the problem only at this time zone? So I'll again get that cross-checked today again. Sorry for that.
Too much traffic coming to India, I guess. Voice calls, too many voice calls.
No, actually, this time I have weekday trainings also sometimes, but okay, no. Okay. So before showing you that thing, let me show you one more screen. Let me go to 8080. 192. Is somebody up? Just a minute. Somebody is enabled. One 127 page here. 127. Just a sec. It's 88 only. What is it? 88 only, yeah. 127, 80, 80. Is Ambari down? I think the Ambari is down. Let me check Ambari. Give me a sec. Just give me a sec. Let me check Ambari. I'll show you that part also. How to look into the individual logs also. I'll just show you that part. Give me a minute. I'm pausing my screen. I'm just checking the Ambari configuration if that is working fine. Why the Ambari is down? Just give me a minute. The Ambari is still down. Ambari is running 7817. Ambari. There's a possibility, sorry. Ambari is running up and running. Shit. I have not enabled it over here. So Ambari by default you have to enable it. I have not enabled it over here. Okay. So this is Ambari UI. I think I shown you in the previous class. So why I'm logging over here, I am just showing you the shortcuts how to go to those different things rather than remembering all those IPs and everything. So if you go to Yarn and there's a something called Quick Link and you can directly go to the Resource Manager UI. So you don't have to remember all these things. That is what I wanted to tell you. So directly if the code is changed or anything is changed, you don't have to remember these things. The IP address, you don't have to remember anything. You have to just say go to this thing and this will take you to over here. So this is a Resource Manager UI. What is resource manager? This is similar to your job manager, job tracker and task tracker. What is container? What are these things? These are similar to your task tracker and job tracker, but are different in the yarn concept. So we'll not go into those things, but as you raise that point, let me show you how to look into those things. So this is the word count program which was ran. So this was ran by this application manager, which is similar again to your job tracker. And let me go to this node. So this was the node which ran it. So here you can see the detailed for each MapReduce program, which node it was ran, where the mapper was ran, on which node the reducer was ran, and so on. So this was there was only one attempt. This was ran over here. So let's go to this. So you can make an entry into your what do you call that, host file to so that you don't have to change this IP address. As I'm changing right now, it's automatically ported to a corresponding thing. Otherwise, you have to change this things like this. So here I can look into the detail. I can also look into the further on details like the reducer, the let me show you some big program which ran. I can even look at the reducer logs, the mapper logs, and things like that. Oops. So I'll just tell you how to make an entry into host file so that this kind of problem you won't face. What I'm doing right now. So see, these are the logs for your mapper. If there's some program which ran for your that thing also, I'll show you the logs for each. So let me see if there was something over here. So here's the task tracker history now. Here we can see that.
So why don't you do the host mapping right now? That way we don't have to type it every time, right?
Yeah, just give me a minute. I'll do the in Windows 8 I have to search. In Windows 8 I have to search where the file is. So rather than searching that out, I'm just doing it. Just give me a minute. I'll do that part also. So see, here I can see the mappers which ran, the reducer were ran, the number of mappers ran, the number of reducers ran. I can even go inside that. I can check their logs. I can check the whole job logs, which are triggered from your basically a kind of job tracker in the yarn, and each task tracker what they triggered. So the one was triggered, one was completed. How many were killed? How many were successful? I can go into the detail of the mapper and can look into this is the mapper. This mapper ran on so and so node. This mapper triggered, so the logs also I can see. So this is a node on which this mapper triggered. These are the logs for which this mapper triggered and things like that. So we can look all those things from your job browser history. And how to go over there? Rather than remembering these things, just use a resource manager UI. Go to the yarn and go to the resource manager UI, and that will directly take you to the resource manager UI. And so where the host file is lying, that probably file lies in your Windows Windows etc Windows. I also don't remember. Let me check. I also don't remember. In Windows 8. Windows 7 is and host etc. Windows 8, it's system 32 driver etc. Yeah. System 32. Drivers. This problem is coming up because today I again used the best laptop with i7 16 GB, so that this problem should not occur of what you people complained last time. Otherwise, I use other laptop for all the trainings. So I am using a new one over here. So this is a host file. You can just edit it and add that thing over here, so that you don't have to change that. So Autodesk. I have to give it right permission. So you have to just change the properties and right permission. And add an entry like this. That is locked. I'll check it while later on it's locked. You have to add an entry something like this over here, so that your URL is converted to the corresponding IP address. So now URL will be converted to 127.0.0.0, what I was doing, right? Okay, and save it. Right now it's locked. I'll check it why it's locked, and so that you don't have to do that thing what I was doing right now. And the file is inside system.out drivers etc. And in the resource manager, you can see all the logs related to your resource as well as the individual mapper and reducer logs. Any other thing? I'll talk about this thing. What is application? What is your container? When I'll talk about yarn. Right now, it won't make any sense to you. But as you raise that point, I show you that UI. So any other thing? I think we are already. Shall we start a new topic? Any other thing? Or it's already 10:15. My watch.
So tomorrow, what are we going to cover?
So tomorrow we'll look into the advanced map reduce, that is the combiner and things like that. What are different things, how to optimize these things using the combiner and partitioner kind of things. And then I have shared you one problem statement. So now I expect you to up your environments so that you people can try out, and if you face any problems, I will try to help you with that thing. And so this is the agenda for tomorrow. And if you want to go anywhere into detail, if you want to look anything into detail, do let me know. We can cover those things in detail. As you people are all from the Java background, I can go into detail of these things. In most of the classes, I don't go into detail of these Java code because people rarely use these things. It's very easy with your Hive and Pig, so people rarely use these things. So, but if all you people are from the Java background, whole of this bag is from Java background and with extensive knowledge of Java. So wherever you want me to go deeper, do let me know. I can go deeper into those part also.
So the API we are using, is it Hortonworks implementation or is it generic Hadoop API?
The POM
All
I've
those
shared.
classes we have.
The POM I've shared with you is, I think, Apache one only. The POM which I have shared with you people is the generic Apache only, I think. Just a second. Let me cross check. I'll just cross check it. I think I have both the Cloudera also, generic Apache also, but I think I've shared with you the generic Apache. Yeah, Apache one only.
Okay. So this is generic.
Yep. Okay.
Yeah, we'll try to see if this environment, we can fix this BIOS issues and get ready for tomorrow.
Sure.
And then we can run some programs and.
Yeah.
We really understand details, once we look into the code and run it.
Yes, definitely. When you will try to run one program, at least the hello word only, then you will get the real feeling. Yeah. Yep.
Okay, I think I mean we have only 5 minutes left, so unless others have anything to discuss, I think we can wrap up today's session.
Sure. So thanks everyone for your time. If you have any other thing, just drop me an email directly. We can discuss those things.
Okay, all right, thanks, Miraj.
Thanks everyone.
Thanks, Manoj.